Right, so we've got fixes in the software now so that we're actually running the motor based on the slip value, which we fixed. The accuracy of the slip was so we've fixed that because we're using the actual frequency from the controller rather than this on the interface. And we've got a pedal, this pedal, which we're using to accelerate the engine. And I'm trying to make it so that that pedal reacts in the same way. So I'll have to do this a few times so you can see what's going on. But basically, this is the amplitude. That amplitude is directly controlled by the pedal. So more pedal means more amplitude, less pedal means less amplitude, right? This fake pedal is a legacy control which will be removed, I guess. Maybe, I don't know. But this is the one to watch. This is the frequency of the stator. Okay, and what happens, the way it works basically is it controls the frequency of the stator based on the slip. So basically it tries to keep the slip within certain bounds, and it alters the frequency to make sure that the slip stays in the same in those bounds. It's not perfect, but it's demonstrating that it works. So as you increase the amplitude, then obviously the slip then will come in as the motor speeds up on its own because it's a base frequency, right? So as you bring the pedal in, it then speeds up the motor to lower the slip, and as the slip lowers, then the frequency of the motor increases. The frequency of the stator increases, so as to keep the slip within a certain bounds, which means basically the motor speeds up. So the net effect is, as you put your foot down on the pedal, first of all, it brings in the amplitude, which means it then gives it the initial speed, right? It spins the obviously it spins the stator because it's got a fixed frequency, and it spins the stator and it brings up the amplitude of the stator, and then obviously the rotor then catches up, right, with a certain amount of slip, and then the frequency then changes to keep that slip within certain bounds. And so basically, effectively, the pedal works as it should. Now then, so what I'm going to do is I'm thinking this is on, so I'm going to just press it down and bring the motor on, and you'll hit the motor's down there, but you can't see it, but you'll hear it. So as I press it down, there you go, and now you can hear it going up, and see how the frequency is increasing and the slip is kept within a certain bounds. Right, that's the equivalent of 60, so I'm going to back off the amplitude. Right, so I'll take my foot off the pedal now, right, and now the motor is slowing down on its own. There's no amplitude, so it's just basically winding itself down. But the slip is kept at, well, it's 5% because I set it like that. So you can see how the frequency is now dropping, right? And basically it's turning down the frequency because the slip's going up. You see, and it's not perfect right now. Okay, now it's dropped to about 30 miles an hour, so I'm going to stomp on the throttle, right? And now you can see how it's spinning up again. Yeah? And there you can see the slip. So this is run through the interface, which is a little bit laggy, so it's not perfect, and eventually this is going to actually be built into the firmware of the controller. I'm just doing it as a test for now. Okay, but what I'm going to do also is I'm going to hold it at 30 miles an hour when it gets down to 30. Right, so I'm going to bring it in, there we go. Right, so I'm now holding it at 30 miles an hour, you can see there. Right, and then I'm going to accelerate it up to 60 by pressing down the pedal, and you can see there's the pedal. Right, so now it's at 60, and I'm going to hold it at 60 by adjusting the pedal, and you can see that the bottom one is the pedal basically, and there it is at 60, and you can see the slip is at about 5%. Okay, so I'm going to drop the speed down now. There we go. And now I'll lift off completely and just let it spin right down. So the next thing I'm going to do is I'm going to stomp the pedal from 0 and see how it reacts from stationary. Right, and what happens basically is that because the amplitude is max, it quickly gets up to speed, the slip quickly gets to a low value, and so then you start seeing the frequency, the VFD frequency going up. Right, so I've just got to wait for it to stop. So this here is an actual animation of what's going on in the engine. It's fed back from the sensor, and so that spinning dot is the actual rotation of the engine, right? And it's fed back from, like I say, you can see there's the shaft RPM, So the shaft RPM is going down, and at the same time you can see the spin, and you know when it's stationary because that then just stops. It's stationary, even though you see you can't really tell too much when it's getting very low. There you go, and it's stopped. Right, so what I'm going to do now is I'm going to stomp the throttle right down to the floor immediately, and you'll see both the amplitude and the fake pedal, which it's not, it's a real pedal, but you'll see they both go straight across, right, and then you will see the motor accelerate. And it didn't work. Why not? Ah, damn it, got a comms problem. Whoa. Oh damn it. I got a comms problem. It stopped talking to it. Thanks for that, you bastard. Right, let's try it again. Okay, wait till it stops again. Yeah, this is it's just unreliable, the interface is unreliable, but it works right now. So stomp. There you go. Now do you see the slip go straight up, and now there's the VFD going up now and accelerating it, and I'll stop it at 60. There we go. I just lifted off at 60. Now you can see that the slip's been held at 5% and the VFD is dropping. The the frequency is dropping in the stator. There you go. Now then, what I did is I stomped on it, and of course the slip immediately came up, pretty much immediately came up, which basically it spun the shaft up to the minimum RPM, right? And it got it in sync, you know, close to sync. And then that's when the VFD then did its business based on the slip, and so it's working. This is working really well. Yeah, and it's a bit unstable because this is a JavaScript interface which is talking to a display, which you should be able to just see in the car there. That one. So it's talking to that, which then passes it on to the controller. So we've kind of got 3 links in the chain, and this one's the slow one because this is a browser. Which is working through WebSockets, and you can see there's the query, so you can see how fast it's going through. And this is a controller, so you can see the controller. Yeah, it's currently got 1.3% free CPU. That's an estimate basically. Yeah, this is the accelerator 20, which is of course the same as that. And this here D, that is the slip. So if I stamp on it again, you can watch the controller and it will react on the controller itself. Let me just get this lined up. Right, so, and go. So you can see the amplitude's immediately gone up, the slip goes right down, and now it's staying at kind of 0.4%. I'll lift it off the throttle, and now you can see how the slip value here, 5%, is the same as this value. It's calculated the same way basically. And here you can see this is the shaft RPM and this is the field frequency, and they are following each other now because this software on here is doing that through the slip, and the slip's held at about 5%, and that's actually programmed in that 5%. Yeah. See? There you go. Yeah. There. And from here you can tell it's stationary because that goes to 100%. And I think this registers 0 as well. 16, 15, 13, 10, 6, 5, still spinning. There you go, 0 ish, 100%. Yeah. So this actually works. So the next stage obviously is to actually add this into the firmware, and also sort out some other things as well to make it more reliable. But the system works.